Hello and welcome to my channel. I'm Dr. Hetal Thakur. In this video tutorial, we are going to see delegates in G#.NET. Let us understand what is delegate. Delegates are reference type variables. It can hold reference to other methods. If you write a statement integer x equal to 5, the value 5 gets stored on the stack. While creating a test y equal to new test, y reference variable will be on the stack and the object will be on the heap. The reference variable holds the reference to the object created on the heap. Here, the delegate can hold the reference to one or more methods. List of methods to which delegate points are known as method invocation list. A point should be noted here. Delegate can only hold reference to the methods whose return type and method signature matches that with delegate. Whenever you are executing delegate, all the methods to which it refers will be executed. It is not that once you have assigned methods to delegate, you cannot change. There are operators available by means of which you can add or remove methods to delegate at runtime. How to do that? We will see in next subsequent slides. And therefore, which methods will be invoked by delegate is known at runtime and not at the compile time. Delegates are also known as type-safe function pointer. How to declare delegate type? For that, delegate keyword is prefixed. You can see the syntax: delegate, return type, name of the delegate, within a parenthesis 0 or more parameters. Here in an example, you can see that first delegate is declared, which does not return anything, as well as it does not contain any parameters. How to create delegate object? Once a delegate is declared, you can create an object of delegate. Like in the previous slide, we have declared delegate, namely first delegate. Now we can create an object of delegate. First delegate FD. Whatever identifier name you would like to give, you can choose. Now, how the delegate can hold the reference to the methods? Meaning, we want to assign methods to the delegate. The syntax is simple. If it is an instance method, the delegate variable equal to instance name dot method name. Observe that there are no parentheses. And in case of static method, the only change is it will be prefixed by class name rather than instance name. For example, for instance method fd equal to t.m1. Here you can assume that t is an object of test class. Or in case if it is a static method, you can write fd equal to test.m2, where m2 is a static method. The way we use primitive variable and we declare a primitive variable integer x and later on we assign a value x equal to 2, or when we are creating a variable at the same time we can initialize integer x equal to 2. Similar thing you can do for the delegate as well. Here you can see that the delegate object is created, first delegate FD. At the same time, it has been initialized with a reference to a method m1, t.m1. And the another change for the static method will be that it will be preceded by the class name. Now later on, you want to add some more methods to the delegate. Plus equal to operator can be used for that. fd plus equal to t.m3. Now suppose that in the previous slide, fd holds the reference to the method 1 m1 Now we also want that it should point to the method M3. So fd plus equal to t dot M3 will do that task. The way we can add, we can also remove the method from delegate. For that, minus equal to operator can be used. And fd minus equal to t dot M3. This statement means now fd is no longer pointing to method 3. Let us understand this practically. A simple project, namely Delegates demo, is created. Here, I am creating a delegate void first delegate fd. First delegate. Now, we are creating a class test. Within that, I am creating a method which matches exactly with the that of signature as well as written type of delegate. Writing here a simple message instance method 1 invoked. A simple message so that we can understand, we can know that which methods are being executed. Similarly, I am creating another instance method, namely method 2, and one more method that will be a static method 3. So I am also changing the message appropriately, static method 3 invoked. Okay, I am done with my class test where there are 3 methods, 2 methods are instance methods and 1 method is a static method. Now let us create an object of test class, new test, and a delegate as well, which is pointing to t dot method 1 as it is instance method. So I have used a t dot method 1. Now we can check if fd is not equal to null. Why do you need to check this one? Because you have to check that fd is pointing to some method. If it is not pointing, then we will not be executing it. So right now fd is holding only the reference to the method 1. So let us observe what is the output that we are getting. So running this program, we expect that as it is holding, delegate is holding the uh, reference to the method 1. So instance method 1 is invoked. Now we can do a changes here. fd plus equal to t dot method 2 and fd plus equal to test dot method 3 because it is a static method. Once again, I would like to check by executing my delegate what is the change in the output. So I am just putting a simple separator line. Okay. Fine. So you can see that earlier it was pointing to method 1, but now it is pointing to holding a reference to method 1, 2 and 3, all of them. So executing a delegate has executed all 3 methods as per the sequence which it has been given. Now let us try to remove one of the method here, t dot method 2, and re-executing the same. So because we have removed the method 2, now fd holds the reference to only method 1 and method 3. So you can see the changes in my output as well. And so in this program we have seen creating a simple delegates and using plus equal to and minus equal to operator to add and remove method reference dynamically. Thank you.